In this video, I will talk about the measurement of acidity and alkalinity, and second is the strength of acid or alkali. For the first one, the measurement of alkalinity or acidity, we can measure it by using the pH scale. And pH value comes from the word power of hydrogen. And we just use two of the letter P and then capital letter H to present the whole term. And because an acid is closely related to the hydrogen ion that can be ionized, so that we use hydrogen ion to define how acidic or how alkali a substance is. And pH value is actually a function, is calculated by negative log and then a bracket H plus and then close bracket, and this bracket in chemistry means the concentration of. So if I put H plus inside, it means that this term, a bracket H plus, means the concentration of hydrogen ion, and more precisely we use the term molarity to present the concentration of hydrogen ion. Molarity 叫做摩爾濃度 and it is calculated by the number of moles of a species divided by the total volume of the solution in dm cube. And dm cube is a unit equivalent to 1 liter, and you will learn the calculation later. So this pH value can be used to show the acidity or alkalinity of a substance, and normally if you are using the universal indicator or pH paper, it will show the scale from 0 to 14. However, if you are according to this equation, pH equal to negative log H plus concentration, you can actually obtain some negative number or some number larger than 14. If you are using a universal indicator or pH paper, then the result will be shown in terms of color. If it is acidic, then the solution or the paper, it will appear in red or orange or yellow. On the contrary, if it is alkali, then it will be blue or purple in color. And if it is neutral, that is pH value equal to 7, then it is green in color. However, those colors are inaccurately detected by your eye, so that some instrument can be used to help you, called pH meter. And it is often used with a data lockup. It means that once the data is detected, then it will be sent to the computer for analyzing and recording. And by using the pH meter, the accuracy can be up to maybe 1 or 2 decimal place instead of just an integer number. And the second way to determine the acidity or alkalinity is by use of other acid-base indicator. For universal indicator, it is a mixture of indicators, so that there will be so many color change from red to orange to yellow and then up to purple. However, for some of the indicator, it has only 2 colors at different medium, and in your syllabus there will be 3: Limex solution or Limex paper. In acidic medium is red in color, and in alkaline medium is blue in color. And then 2 more is that methyl orange, and then the phenomenon you learned in the rust indicator, and their color in acidic medium and alkaline medium are shown as follow. For methyl orange is red in acidic medium and then yellow in alkaline medium. And previously, what you learn is that it will appear acidic. It means that when the pH value is smaller than 7, then it has one color, and then if the pH value is larger than 7, then it will have another color. But it is not the story. For each of the indicator, we have a thing called a working range of it. Say for example, for methyl orange, its working range is 3 to 5. It means that when the pH value is smaller than 3, then it appears in red. And then if the pH value is larger than 5, then it will appear yellow. And when the pH value is between 3 to 5, it means that it gradually changes its color from red to yellow that is somehow like orange in color, so that the name of it is called methyl orange. And then the other indicator is that called phenolphthalein, and it has a working range of 8 to 10. The meaning of it is that if the pH value is smaller than 8, then it will be colorless. And if the pH value is 10, that is out of the working range of it, then it will become red or pink in color, depends on how much indicator you add into the solution. It means that during this working range from 8 to 10, then it will turn from colorless to pink gradually. And the reason why we would like to use these kind of indicator with different working ranges, that for different combination of the reactants and also the resultant solution, they will have different resultant pH value. So if we want to use indicator to show people that okay, if a reaction it has been completed or not, we must need different indicator with different working range. And for these two indicator, they show distinct and sharp color at pH value around 7, just around 7. For methyl orange is suitable for some finally acidic medium. And then for if you are using phenolphthalein, if the resultant solution is slightly alkaline, then it will be suitable because its working range is 8 to 10. And these two indicators are extremely useful in quantitative analysis to determine what is the concentration, what is the amount of the substance in a sample. And you will learn the detail later, and you will learn a method called titration, 滴定法. Oh, and then the second part is how to divide the strength of acid and how to experimentally show people which acid is stronger or weaker. And the way we define whether an acid or alkali is strong or weak depends on the extent of ionization. If a substance or if an acid it can completely ionize, then it is a strong acid. If it can only partly ionize, then it will be a weak acid. So here we just apply the definition and to see why sulfuric acid is regarded as a strong dibasic acid. And there are 3 terms you need to explain to other people. First of all, why is it an acid? What's the definition of it? Okay, hydrogen containing molecule. Then okay, they will ionize in water to give hydrogen ion as the only type of cation. So that it is an acid. And there are 2 things you have to explain. The second one is why is it called dibasic? So dibasic means that one molecule of it can ionize 2 hydrogen ion in maximum, or in other words, it has 2 ionizable hydrogen. Oh, and finally, is why it's called a strong acid. And as I mentioned before, it depends on the extent of ionization. If it is strong, then the meaning is that this acid can completely ionize in water. And for this kind of acid, it can completely ionize in water. We use straight arrow in between. So the equation when it dissolves in water is that H2SO4 and then a straight arrow, irreversible sign to form 2H plus with a sulfate ion. And that's it. Oh, and maybe you try the next example yourself first. Why ethanoic acid is a weak monobasic acid? And even lower acid have this formula, CH3COOH. Why is it an acid just the same? Is it okay? And then why is it weak? Can it completely ionize? Okay, it cannot completely ionize, or we say that it only partly ionize. And we can actually merge these two definitions together. CH3COOH is a hydrogen containing compound that only partly ionize in water to give H plus as the only type of cation. Can you see that how I merged the two definitions? I just add only partly ionized in the definition of acid to represent that okay, it is a weak acid. And then the third thing, why is called monobasic? How many ionizable hydrogen does it have? Okay, there's only one ionizable hydrogen ion. Oh, is it okay? Oh, and then go to the equation part, because this time is a weak acid, so we use a reversible sign in between to represent the idea that it only partly to give CH3COO minus the corresponding evaluate ion and hydrogen ion. Oh, and the reversible sign means that, say for example, originally there may be 1 mole of ethanoic acid, and then without any hydrogen ion and ethanoate. And then finally, maybe only 0.3 of the acid is converted into hydrogen ion and the ethanoate, but still 0.7 mole of it is left behind in forms of the acid molecule itself without ionization. Can you see the meaning of partly ionized? Oh, and after you know the definition for strong or weak acid or alkali, then it's time for the experimental part. When you have two acids, say for example in this case, hydrochloric acid and ethanoic acid, how can you know that which one is a stronger acid? What is the definition of being stronger? Being stronger means that it can more completely ionize, and in order to make it a fair test, we have to ensure that the two solutions, they have the same molarity and then same volume. Is it okay? Then what do you think? Which of hydrochloric acid or ethanoic acid will have more hydrogen ion? Okay, hydrochloric acid, because it is strong, so that it will have more hydrogen ion, and if we calculate the molarity, then it will also be higher. So can you think of some method? If the concentration, the molarity of hydrogen ion is higher, then how can we measure it? Or maybe I draw you several setups and you think of why they work. Oh, this is the first method. By connecting a light bulb with battery with two inert electrodes. Inert means it's chemically unreactive. And if I put into some acid, then why can acid conduct electricity? What does it have? What do they have? Well, they contains mobile ions for conducting electricity. And what if it is a stronger acid? Okay, it is a stronger acid means that its molarity of hydrogen ion is higher, and then it will have more mobile ion. Then what happened to its electrical conductivity? Okay, its electrical conductivity will also be higher if it is a stronger acid. Oh, and the reason is that for hydrochloric acid is a stronger acid, so that it is more completely ionized. So that the hydrogen ion concentration is higher means that the mobile ion concentration is higher, so that a stronger electrical conductivity. Can you see the idea? Oh, and then the second method is that we can put a piece of reactive metal inside. And then maybe you think of why first. Well, what will be the difference? Well, again, if you write down HCl, AQ is a stronger acid and it completely ionized, while CH3COH only partly ionized. Then what happened for the H plus concentration in HCl? Or it should be higher. And then finally, what will happen if the molarity is higher? Oh, then the rate of reaction will also be higher. Is it okay? It's because what means by a reaction? The reactant, they must collide with each other. The more concentrated the solution is, the more easy for the reactants to collide with each other. It means that the rate of reaction it will increases. So if you really put a piece of, say for example, zinc into HCl, HCl react with metal with a faster weight. And you can actually count the number of bubbles. If the rate of bubbling is higher, then the rate of reaction is higher. Or other method is that you can put the same amount of magnesium or zinc into the acid, same molarity and volume, and then to record the time for complete reaction to occur. If it takes a shorter time for complete reaction, it means that the rate is higher. This is the two ways to measure the rate of reaction for this experiment. Oh, and finally, just make use of the pH meter with data logger. Oh, can you tell me why? Again, in the same sentence, okay, HCl is a stronger acid, so that it will more completely ionized to give hydrogen ion. Then what means by pH value? A pH value equals to negative log hydrogen ion concentration if H plus increases in concentration, and log is an increasing function. So when the concentration of H plus increases, this log term will also increases. And when we add this negative sign before it, then the trend will just the opposite, so that the whole pH value, it will decreases. Is it okay? So that the stronger the acid, the more the hydrogen ion inside, the higher the concentration of hydrogen ion, the lower the pH. So the expected result is that HCl shows a lower pH value than ethanoic acid. Or is it clear about these three methods for measuring the strength of hydrochloric acid comparing with ethanoic acid? And all is just about the hydrogen ion, the concentration of hydrogen ion matters. And you can apply the same idea apart from comparing the strength of acid. You can also compare the strength of alkali. However, for strength of alkali, you can just compare the pH value. If it is a strong alkali, then the pH value will be higher. And also use the electrical conductivity method. The stronger the alkali, then the higher the electrical conductivity. However, you cannot put a piece of reactive metals into alkali. Is because it is one of the acidic properties for alkali is not applicable. Is it okay? And also there are other uses. Say for example, if you want to compare the basicity of H2SO4 and HCl, again you just put the same molarity of acid, same volume of acid for fair comparison, and then to measure their maybe pH, their weight, and also the electrical conductivity. Because sulfuric acid is dibasic, so that more H plus can be ionized. It means that the concentration of hydrogen ion is higher, then it will have a higher electrical conductivity, faster rate with zinc or magnesium, and lower pH value by comparing with HCl. And of course, you can do something like comparing the concentration of the two acids. Oh, and the final part here is to tell you the relationship between these three items: concentration, strength, and also basicity. They are three totally different concepts. Sometimes they are related, sometimes they are not. So the conclusion is that there is no relationship in between. You can have concentrated strong acid, concentrated weak acid, dilute acid, dilute strong acid, and also their basicity can be different from each other. So there is no strict relationship between these three concepts. And the idea, I can give you some example. Concentrated hydrochloric acid, no matter it is under concentrated or diluted environment, HCl is still a strong acid because of its nature. And say for example, if you have concentrated ethanoic acid and dilute ethanoic acid, and because the nature of having this C double bond O OH group means that this ionizable hydrogen can only partly ionize. It's the nature of this group. So then no matter its concentration is high or low, ethanoic acid is still a weak acid. Is it clear? And it's all about strength of acid and also acidity and alkalinity and their measurement.